This is our 10th experiment, which is the flexural strength of concrete experiment. Starting with the purpose, proceed to the apparatus needed, experimental procedures, result, and lastly the discussion and conclusion part of this experiment. The purpose of the experiment is to determine the flexural strength of Portland cement concrete by using a simple beam with third-point loading. The flexural strength of concrete is a measure of concrete quality. The apparatus we need for this experiment is first, the loading machine capable of applying loads at a uniform rate as well as the computer to show the loading result. Our previously made beam concrete are also needed. Don't forget tissues, marker pen and also a measuring tape. After everything are prepared, we are ready to begin the experiment. First thing we need to do is to remove the beam specimen out of the curing tank carefully and dry the specimen surface using thick tissue paper to make a saturated surface dry condition. Then measure the depth, width and the span length of the specimen and put it in our record. Measure the middle third of the span length and mark a line on the top surface. After that, measure the distance between two bearing blocks and mark the distance on the rough surface. Make sure that the distance from both lines to each end of the specimen are the same. Turn the test specimen on its sides, with respect to its position as molded, and center it on the bearing blocks. Center the loading system in relation to the applied force. Bring the load applying blocks in contact with the surface of the specimen at the center point between the supports. If full contact is not obtained, add no load between the specimen and the load applying blocks and the supports so that there is a 25 mm or larger gap in excess of 0.1 mm. Grind or cap the contact surface of the specimen or shim with leather strips. Apply the load rapidly up to approximately 50% of the breaking load. Thereafter, apply the load continuously at a rate that constantly increases the extreme fiber stress between 860 kPa and 1210 kPa per minute until rupture occurs. Observe the appearance of fractured faces of concrete and type of fracture. As a precaution, make sure that the distance from the bearing block to each end on both sides of concrete beam are the same as possible. Make sure that the center of the beam is perfectly perpendicularly located at the center of the load applying block. Turn the test specimen on its sides to make sure that the load is applying on the smooth surface instead of rough surface. To prevent any formation of defect on the surface, be careful when taking the beam specimen out of the curing tank and when drying the specimen. Make sure the load indicator is set to 0 prior to the starting of the test. Now it's time to see the result. As we can see, the fracture initiates in the tension surface within the middle third of the span length. The modulus of rupture is calculated as shown here. By using all those formulas given, these are the outcomes of our experiment. More detailed information about the results obtained are stated in the table shown. Finally, we've reached the final part of our video, which is the conclusion and discussion part of our experiment. In this experiment, ASTM C293 standard had been used. The entire load is applied at the center span. The modulus of rupture will be larger than ASTM C78 standard. The maximum load is present only at the center of the beam. After that, according to the standard ASTM, the specimen dimensions should be 152 mm by 152 mm in cross-section and a length of not less than 508 mm for a maximum aggregate size up to 50 mm. However, the specimen we use in experiment have cross-section of 146 mm by 149 mm. In the previous experiment, which was on 29th of October 2019, our team has added too much water into the concrete mixture, so that the concrete specimen has high workability but relatively low strength. In conclusion, modulus of rupture is a measure of the tensile strength of concrete beams or slabs. It identifies the amount of stress and force a concrete specimen can withstand such that it resists any bending failures. The higher the modulus of rupture, the higher the load it can withstand. That is the end of our video. Thank you.